Hi everybody, I'm Greg Fishel. Welcome to bonus weather video number 1 for this week. And we've actually talked about this fairly recently. I think I'm just going to describe it or show it to you graphically in a slightly different way. Now that we are at January 2nd, we are about a month removed now from the earliest sunset. The sunset started getting later in December after about the first week, and has been getting later ever since. Not at a rapid rate, but it has been getting later. And the only reason that the days have been getting longer since the solstice, since December 21st, is that the sunrise has been getting later, but not at as quick a rate as the sunset is getting later, okay? So the days are getting longer, and once the sunrise reaches its latest point, which is pretty close to now, or will be very, very shortly, then it will start to back up. And so it'll be getting earlier, the sunset will be getting later, and the two will be diverging, as most of us think it should be doing as we head on through the months of January, February, and beyond. But there is that period of time between about the 5th of December and about the 6th of January where things aren't quite symmetrical. All right, so let's go on ahead and take a look at this in graphical form here, and I will put myself in the corner so you can see this. And hopefully you can see the labels there at the bottom. Now, on the y-axis on the left, this is, in a sense, military time, okay? So if you see 5.00, that's 5 o'clock. If you see 10, it's 10 o'clock. If you see 20, it's 20 o'clock or 8 o'clock p.m., okay? So that's basically what's going on there. At least with regard to the top and the bottom lines. This is the sunset time up here, how it varies through the year, and this is the sunrise time down here. And then the green line is actually the length of day, okay? And this is where it gets a little bit interesting. So let's go on ahead here and put in this line. This is the longest day of the year that'll be coming up this year on the 20th of June. That's when the summer solstice will occur. But, and this is when the shortest day will occur on December 21st. So you can see how the green line is at its highest point on the left, the lowest point on the right. However, the earliest sunrise, okay, actually occurs about the 11th of June, okay? So you can see where that blue line actually reaches its lowest point about 10 days, 9 or 10 days before the solstice. And then the latest sunset actually occurs about a week after the solstice, okay? And again, this is all because of the fact that the Earth is not moving at the same rate around the sun, the same speed around the sun at various times of the year. The paradox is the fact that we're actually closer to the sun now than we are in July, okay? It's the angle at which the sun's rays come in that determine whether or not we're hot or cold, but we're actually closer, and so we move faster this time of year around the sun than we do in the month of July. And so it's like the Earth-Sun time system is not constant like our time system is. And so it leads to these asymmetric qualities right around the solstice times. And the same thing about December 21st, but it's a little bit more dramatic here. The earliest sunset actually occurs about the 5th of December, about more than 2 weeks before the winter solstice, and then you have to wait until about the 7th of January to get the latest sunrise, okay, which we're coming up on here over the next few days. So again, once you're outside of these windows in here and in here, then things behave as you think they would, wherein the days are getting longer, the sunrise is getting earlier, the sunset is getting later, and when the days are getting shorter, the sunrise is getting later and the sunset is getting earlier. But in these windows, right in here, and also in here, it doesn't quite work out that way. Now, if we take a look at the times of year at which the rates of change of the length of day are varying the most, here we look at this. So on the 21st of December, the rate of change is 0 because you're at the shortest day of the year, okay? And then the days start to get longer, but the rate at which they get longer is actually accelerating and reaches a maximum around the equinox, right around March 19th, okay? And so that's when the days are getting longer at the quickest rate. They get longer all the way through here, okay? Actually, all the way up until you get to, the summer solstice around the 20th of June or 21st of June. But the rate at which the days increases peaks here right around the equinox, and then the rate of increase slows and slows and slows, and then once you get to the first day of summer, it is 0, and then the days start getting shorter, and the rate at which the days are getting shorter maximizes around the autumnal equinox, which is about the 21st of September, and then after that point in time, the rate at which the days are getting shorter begins to slow down. Does that make sense? Okay, so it's not a linear increase. In other words, once we get past December 21st, the days start getting longer at a slow rate, and then they begin to ramp that rate up, and it keeps ramping up until about the 21st of March. That's when we're getting the biggest day-to-day jump in the length of the day, and then that rate begins to slow down again until it gets to 0 on the longest day of the year, and exactly the opposite occurring as we head toward the shortest day of the year. So right around September 21st, that's when you're losing light at the quickest rate, okay? All right, I'm going to stop there. I hope that makes sense. For those of you that remember calculus, back in your maybe high school or college days, you remember the first derivative is the slope of the line, and then the second derivative was whether or not the line was curved in a certain way. And if somebody told you where these derivatives were equal to their maximum values and zeros, you could actually estimate what the curve of the function would look like just by knowing the values of those first and second derivatives. Does that make, you remember any of that? Those of you that are geeky and mathematically oriented? All right. Okay, folks, that is bonus weather video number 1 for this week. Number 2 will be coming up tomorrow, number 3 on Friday, and we'll have the next daily weather update, of course, for you coming up on tomorrow afternoon. So you all have a good one, and we'll talk to you then. See you later, everybody.